Welcome to GSM Maths Academy. Now I would like to explain important concepts of real numbers of class 10. This is our first chapter of class 10. Firstly, one must aware about the real numbers. Real numbers is represented by R, and set of real numbers is a union of rational numbers and irrational numbers. That means R is equal to Q union Q dash. Here Q means rational numbers, Q dash means irrational numbers. And in this, what are the important concepts that are there that we are going to discuss? First concept that we are going to discuss in this, that is of Euclid division algorithm. Before going to discuss about the Euclid division algorithm, let us see this division. Here I have divided this 21 by 4 in the two methods, that means in two manners. That is of 4 on dividing 21 by 4, you get a 5 as a quotient, remainder is 1, and on dividing 21 by 4, in this we got 4 as a quotient and 5 as a remainder. Which one of this is correct? Usually we'll treat this is a correct, this is correct, and this is wrong. Why this is wrong? Means, as for the convention, while dividing any number by a divisor, remainder should be less than the divisor. Remainder should be less than the divisor. In the second case, what is the remainder? That is 5. 5 is greater than the 4. 5 is greater than our divisor 4. So this is wrong. So what is correct? First case is correct. And let us come back to our topic, that is division algorithm. Division algorithm says that given two positive integers a and b, there exists a unique pair of integers q and r satisfying an equation of a is equal to b into q plus r, where 0 less than or equal to r is less than the b. That means what? Here, if we divide the a by b, you may get some quotient and a remainder. So for this verbal form, the equation form of the division, an equation form of the division is called the division algorithm. We already learnt about division algorithm in the form of dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. This is what? This is an equation form of our normal division. So here also Euclid division is not something new. This is we already learnt in our previous classes, in the small classes, that is of Euclid division algorithm. That is a is equal to b into q plus r, and what are the conditions for r? Means 0 less than or equal to r less than the b. That means on dividing a by b, you will get r. This r must be less than the b. That means r may be 0, r may be equal to 0, and r may be less than the b. So that is what condition we have given. And if you observe these two positive integers, let us observe an example. If you take two positive integers 12 and 20, on dividing 20 by 12, we can subtract only once 12 from the 20. So you will get a remainder is 8. That means 20 is equal to 12 into 1 plus 8. Here quotient is 1, remainder is 8. That means what is Euclid division algorithm? Division algorithm is a verbal form to write down the division. That means it is an equation form of writing of the division. Is said to be what? Division algorithm. And there is one important application regarding this Euclid division algorithm. This division algorithm will apply to find out HCF of two given numbers. We can find out the HCF of two given numbers by using this division algorithm. Now, let us see the next concept. That is how Euclid division algorithm is stated for only for positive integers, but it can be extended for all positive integers, for all integers, where a is not equal to 0 and b is not equal to 0. That means in the definition of Euclid division algorithm, we took that any two positive integers a and b we said, but this can be applicable for any integer, no matter whether it is a positive or negative. But in our definition, we took it as a positive. But this can be extended for any integer. That means it can be applicable for negative integers also. And just now I said to you, Euclid division algorithm can be useful to calculate a HCF of given numbers. So let us see that how we are going to apply Euclid division algorithm to find out HCF by taking an example. Use a division algorithm to find out HCF of 900 and 270. Before applying Euclid division algorithm, let us see how we used to do this HCF in the long division method. In the primary classes, we used to find out HCF of any two numbers by using continued division method or long division method till we get a remainder 0. That means first step what we supposed to do is we need to divide the larger number by smaller number. That means we need to divide the greater number by smaller number. Here greater number is 900, smaller number is 270. So on dividing 900 by 270, you will get a quotient is 3 and remainder is 90. And this is one step of the division. Here we got a remainder as 90. So we will continue the division. With this remainder, we divide this divisor. That means this divisor of the first step becomes a dividend for the second stage of the division. So on dividing 9 and dividing 270 by 90, we get a quotient as a 3. We get a quotient as a 3 and remainder is 0. As we got a remainder 0, in this stage, at this stage, what is the divisor? That divisor becomes HCF. In this stage, at this point of the time, what is the divisor? Divisor is 90. So HCF is 90. HCF is 90. For this, HCF is 90. So this is our continued division method to find out the HCF of given numbers. Now, how we are going to apply Euclid division algorithm to find out the HCF of the same numbers. So, see here Euclid division algorithm is not something new. This is a Euclid division algorithm is an equation form of a writing of an normal division. So this division only will write in the form of equation so that you will get an HCF as a 90. Here in the first stage of division, what we did, 900 is divided by 270 by 3. 270. So that what we got, quotient as a 3, the remainder is 90. In the second stage of division, we divide this 270 by 90. So we get a quotient as a 3, remainder is 0. So here divisor is 90. This is only HCF. Same steps will write in an equation. So it becomes a Euclid division algorithm. Let us observe that how I did this answer. Okay, before writing the answer for this, first we must write the Euclid division algorithm. What is division algorithm means? For given two positive integers a and b, there exists a unique pair of integers q and r such that a is equal to b into q plus r, and here 0 less than or equal to r is less than the b, where a is greater than the B. That means on dividing A by B, there will be a quotient and remainder. This is only Euclid division algorithm. So here we have to divide the greater number 900 by the smaller number B, that is of 270, so that we get a quotient is 3 and remainder is 90. Here remainder is 90 is not equal to 0. So we have to consider this division of the 270. We have to consider this division of 270 by 90 and apply division algorithm. Apply division algorithm in the sense, again this division, second stage of division, we have to write in the form of equation. That means in this dividend is 270, dividend is equal to divisor is 90 into quotient is 3 plus remainder is 0. In this stage, what we got? Remainder is 0. This remainder has got now 0. So our procedure stops. Divisor at this stage is 90. The divisor at this stage is 90. So this divisor is said to be as an HCF. Therefore, HCF of 270 and 900 is 90. Now, let us see the next concept. That is of fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Sir, what is the meaning of fundamental theorem of arithmetic? What is the definition of fundamental theorem of arithmetic? Means every composite number can be expressed as a product of primes, and this factorization is unique. Apart from the order of the factors. Sir, firstly we have to understand this word factorization, then afterwards prime factorization. Okay, so let us take an example. I took a number 24 and I can write this 24 as a product of 8 into 3, 12 into 2, 4 into 6, like this. And 24 can also write it as a 2 into 2 into 3 into 2. Here, this first three methods, if you observe, we have written a number 24 as a product of two numbers or more than the two numbers. Means if you write a number as a product of its factors, that is said without factorization. In that factorization, if only primes are involved, see in the fourth stage, in this factorization, we involved only 2 and 3, so only primes are involved. So this is said without prime factorization. Here we should understand the definition of prime numbers and composite numbers. Prime numbers means what? The numbers which are having only two factors. Prime means what? The numbers which are having only two factors are said as what? Prime number. Composite numbers means what? Other than prime. That means if a number has at least three factors, then it is said as what? Composite number. Now, if you take any composite number that can be expressed as a product of primes, means that can be written as a product of primes, means that can be prime factorization in a unique manner apart from the order of the factors. That means if you take a 24, this 24 can be write as a 3 8s, 2s, 2 4s and 2 2s. That means 24 can be written as 3 into 2 into 2 into 2 we can write, or this same 24 can be written as 2 into 3 into 2 into 2, or this can be written as 2 into 2 into 3 into 2, or 2 into 2 into 2 into 3. So same 24 can be factorized in a unique manner. Unique manner means what? By using only same prime numbers we can write, and apart from the order of the factors. That means here no matter in which order the prime factors are involved, that prime factorization is unique. That is what fundamental of theorem of arithmetic. And there is a one interesting application for this fundamental theorem of arithmetic. By using this, we can prove the given numbers as a composite number. To prove the given numbers as a composite number, it's enough to write that in a composite number as a product of primes. That means if you want to prove the number 15, if you want to prove this as a composite number, so if you can write it as a product of primes as 5 into 3, so from the fundamental theorem of arithmetic, 15 is written as product of primes. If it is written as product of primes, then it is a composite number. This is an application where we will use to solve the problems of the exercise. So this is an important theorem. Okay, next, say the next concept in this, the fundamental theorem of arithmetic useful to calculate HCF and LCF. This method is also known as, also called as a prime factorization method. This method is also called as a prime factorization method. This prime factorization method, to find out HCF and LCM, we followed in our smaller classes. Okay, same method we followed in the smaller classes. Now let us say the next concept, next synopsis, that if prime factorization of number contains only 2 and 5, if prime factorization of number contains 2 and 5 as a factors, then that number is ends with a 0. That it is 0. If prime factorization of number contains 2 and 5 as a factors, that number is ends with a, that it is 0. This is also an important topic. Based on this, there is a one question in your exercise. Let us see that problem, how we are going to apply this fundamental theorem of arithmetic and that concept. Let us see this. Check whether 6 to power of n can end with the digit 0 for any natural number n. Check whether 6 to power of n can end with the digit 0 for any natural number n. For that number 6 to power of n ends with the digit 0 for any natural number n, it should be divisible by 2 and 5. It should be divisible by 2 and 5. From where we got this concept? Means in this prime factorization, if a number in the prime factorization of number contains 2 and 5, then only that number ends with a 0. So 2b ends with a 0. 6 to power of n should have 2 and 5 in the prime factorization. But if you observe this 6 to power of n, prime factorization of 6 to power of n, that can be written as 2 to the power of n into 3 to the power of n. That means in this 2 is there, but 5 is not there. Since 5 is not present in the prime factorization of 6 to the power of n, so no natural number n for which 6 to the power of n ends with a digit 0. Now this is how to solve this problem. Now let us say the next problem based on fundamental theorem of arithmetic. That is of how will you show that 17 into 11 into 2 plus of 17 into 11 into 5 is a composite number, and explain. If you take this, we have given it 17 into 11 into 2 plus of 17 into 11 into 5. If you observe this, in this expression there are two terms. This is the first term before the plus, and this is the second term after the plus. In these two terms, 17 into 11 is a common. on taking 17 into 11. This can be written as 17 into 11 of 2 plus 5. That is of 17 into 11 into 7. That means given expression. This is a numerical expression. This numerical expression, I wrote it as a product of 17 into 11 into 7. That means given expression is written as product of primes. So, according to the fundamental theorem of arithmetic, if a number expressed as a product of primes, then that is a composite number. If this is a composite number, this is another way to write our expression. So, our expression, that is of 17 into 11 into 2 plus of 17 into 11 into 5 is also a composite number. This is an application of fundamental theorem of arithmetic, and I will try to cover the remaining concepts of our first chapter in our next video. If you not subscribed to my channel up to now, please subscribe and like my channel. Thank you friends for watching the video.